Let us see how a two-dimensional array is managed or handled by a compiler. In our program, we declare a two-dimensional array like this. Suppose I am declaring an integer type array of dimensions 3 cross 4, 3 rows and 4 columns. Then this is how 2D array we draw on paper. We visualize that this is how we got a two-dimensional array. Any element we can access with the help of its row number and column number. So this is A of 2, 1. But the reality is, during execution, the actual memory allocated will be linear. It will not be in terms of rows and columns, but it will be like a single dimension array. So total 3, 4, 12 locations are there. So here we will have 12 locations of type whatever you have mentioned here. So it's an integer, so 2 bytes I am taking here. Now these are total 11 location, and assuming that the starting address is 200, so on 2 bytes I have increased, and the last bytes address is 222 and 23. Now the problem is how the elements of two-dimensional array are stored in single dimension array. How the mapping is done. So there are two methods of mapping. First one is row major mapping, and second one is column major mapping. So these are the two representations of a 2D array mapped on a single dimension array. So we call it as row major mapping or row major representation, column major mapping or column major representation. So we'll learn about both. So first let us look at how row major mapping is done. Let us look at row major mapping. See, we assume that we have a two-dimensional array and the elements are organized like this. But the reality is they are stored in a single dimension array. How they are stored? So they are stored row by row, row by row. So in row major mapping, the elements are stored row by row. So I will copy these elements row by row. So first row elements are A00, 01, 02, 03. So I will write them here. A00, this is the first value in the first row, 01, 02 and 03. So this is row number 0. This is index 0. So I have completed the first row, that whose index is 0. Now I will write down the elements of next row. This is row index 1. Then the last row A20. So this is row index 2. So that's how the elements of that two-dimensional array are mapped on a single dimension array row by row. So this is row major mapping. Now we need a formula that should be used by a compiler for accessing that two-dimensional array. Let us take one example and frame a formula. Suppose I want to access an element at index A of 1, 2. This is the element. A of 1, 2 is present here. Now in our program we will be writing like this, like say A of 1, 2 I want to store the value 10. Then that A of 1, 2 has to be converted in the form of an address by the compiler. So already we know that the addresses cannot be known at compile time. So compiler writes the formula for obtaining an address. So let us observe what should be the formula. So for getting the address of a location A of 1, 2, this ADD is for address. Now to reach here, that is 1, 2, that is present here. To reach here, the starting address is 200, okay, 200. Then I should leave all the elements of one row, that is row 0. I should leave all these elements. So how many elements are there in a row? 1, 2, 3, 4. That is equal to number of columns. So I should leave 4 elements. Okay, 4 elements I have left. Then 200 is this index. If I leave 4 elements, then 1, 2, 3, 4. So here I was in the beginning of the first row. Now here I am in the beginning of the next row, that is index 1. So here, so from here, how many elements I should move further? 1, 2 elements. So I should move further for 2 elements. Then this should be multiplied by, there are 2 bytes for each element because it's integer. So this is 2. So this is 200 plus 6 into 2 that is 212. Yes, I got the address. So I have just worked out by taking the addresses and the index, and I got the address, that is 212. Now let us try for one more element. Let us take this element 2, 3, a of 2, 3. So address of a of 2, 3. So if you see that a of 2, 3 is at address 222. So I should get this one. Now let us follow the same method. First take base address 200, then. From here I should skip 2 rows. So 2 rows means 2 into 4 elements in each row. See, 4 elements and 4 elements. So I should skip 2 rows. Thus I will be in the beginning of this third row, that is row index 2. So it means earlier this was 1 into 4. Now this is 2 into 4 plus. Once I skip first row, I am here. Then I skip one more row, I am here. That I am skipping 4 elements for each row. Then from here I should move by 1, 2, 3 elements. So that is 3 elements. This whole thing should be multiplied by 2. So how much it gives? This is 4 to 8 plus 3, 11 into 2, 22. So this will be 222. So yes, I got the address. Now from these two examples, we are in a position to write a formula for it. So address of any index a of ij. We take I and j for representing the indices. So this is L0 plus. L0 is the starting address, that is the base address, L0, location 0, plus this is I into number of columns. So let us call this as m cross n. So this is n plus this one is 3, third element, so that is j, and this whole thing multiplied by w. So this is the row measure formula used by compilers for obtaining the address of elements of two-dimensional array. Two-dimensional arrays are accessed using 2 indices, but actually they are kept in a single dimension array which needs just one index or the address. So the address is obtained like this. So this is about row measure. Now one more thing. See, if a language is allowing indices starting from 1 onwards, then how the formula looks like. So I'll just remove this and show you here. If a language is allowing indices from a of 1 to 3 and 1 to 4. I will not work out everything. Directly I will write on the formula. So the address of any location a of ij can be obtained by L0 plus. See, already we have seen it for single dimension. This I minus 1 was used because the indices are starting from 1 onward. So here it will be I minus 1 into n plus j minus 1 also, then multiplied by word size, that is the data type size. So this is the formula. See, in C++, array indices starts from 0 only. So C++ uses this formula. C language and C++ language follows row measure representation and they use this formula. But if any language is allowing indices from 1 onwards, then it has to use this formula. Now when it comes to 2 dimension, let us count the number of operations done. 1, 2, 3, 4. And here 1, 2, 3, 4, 5, 6. So 2 extra arithmetic operations are performed. So this formula will be little slower or costly in terms of time. If you have many elements and the dimensions are very large, then accessing all the elements will be very time consuming using this formula. So that is the reason the languages like C++, they start indices from 0 only. They allow indices only from 0 onwards, so that the formula is little simpler than the other formula. Now next, let us frame a formula for column measure mapping.